Hi everyone, I am Dr.I.JANNATHUL FIRTHOUSE, Assistant Professor of Mathematics, A.D.M.COLLEGE for Women, Autonomous, NAGAPATTINAM. Today we are going to see the topic in Operation Research, solve UV method using Northwest Corner Rule. Hi, now we are going to solve the problem in Operation Research in UV method using NWC, that is Northwest Corner Rule. First of all, you have to solve the problem using Northwest Corner Rule, that is NWC method. To obtain an initial basic feasible solution using Northwest Corner Rule, then we have to apply UV method to find the optimal solution. Okay. First of all, what is the Northwest element? We see in the previous video what are the methods using in Northwest Corner Rule. Northwest element. What is the Northwest element in this first step 1? 11 is the Northwest element. So the row element is 250 and the column element is 200. So which one is the minimum of 250 and 200? 200 is the minimum. So you have to allocate a 200 in step 1 and subtract 250 minus 200. We get 50 and the first column value, that is 200, is vanished. So the first column is also vanished. Okay. Step 2. In step 2, what are the elements? 13, 17, 14, 18, 14, 10, 24, 13, 10. Okay. The row elements are 50, 300 and 400. So what are the column elements? 225, 275, 250. Which one is the Northwest element? 13 is the Northwest element. So we are find the UV method using Northwest Corner Rule. So we have to allocate another one is 13. The row element is 50 and the column element is 225. Which one is the minimum of 50 and 225? 50 is the minimum. So subtract 225 minus 50, that is 175. So the 50 is to be vanished, the first row is to be vanished. In step 3, what is the remaining elements? 18, 14, 10 and the 24, 13, 10. Okay. So the row elements are 300 and 400, 175, 275 and 250. You have to calculate 300 and 400 is 700, 200 and 225, 525, 600, 700. Okay, the Northwest element is 18. So we have to allocate row element is 300 and the column element is 175. Which one is the minimum? 175 is the minimum. So remaining 125. Okay, the 175 is to be vanished. So the first column is to be vanished. Step 4. What are the remaining elements? 14, 10 and 13, 10. So the row element 125, 400, 275 and 250. Which one is the minimum? 125, 275. 125 is the minimum element. Obviously, we have to allocate 125 and subtract 275 minus 125, that is 150. Okay. So, which one element is the vanished element? 125. So, obviously, the first row is to be vanished. Next, step 5. 13, 10. 400, 150, 250. So 13 is the northwest element, so we have to allocate 150. So 400 minus 150, obviously 250. The final answer is 10, 250 and 250. So we are getting. So we have to find the initial basic feasible solution using NWC. So what are the allocated elements to put in the one table? 11, 13, 17 and 14, 16, 18, 14, 10, 21, 24, 13, 10. What are the allocated elements? 11, 200, 13, 50, 18, 175, 14, 125, 150, 13, 150 and 10, 250. Now we are going to find the optimum basic feasible solution using UV method. So finally we got this table using NWC method. Okay. 11, 13, 17, 14, 16, 18, 14, 10, 21, 24, 13, 10. So the assigned value is 200, 50, 175, 125, 150, 250. So we have to assign the value U1. We have to assign the value U1 equal to 0. And you have to concentrate the original allocation. These are all the original allocation of this table. Okay. So U1, U2, U3, V1, V2, V3 and V4. We find these values. Okay. So U1 equal to 0. You have to see the original allocated value. What are the original allocated value? That is 200. That is, the cell value is 11. So 11 minus 0 is equal to 11. And the original allocation is 13 cell value. So 13 minus 0 is also 13. So now we have to see the another original allocation, that is 175, 18, the cell value. So the cell value 18, 18 minus 13. 18 minus 13 is 5. Okay. So and using 5, you have to find the cell value 14, the original allocation. So 14 minus 5 is 9. Okay. So you have to see the original allocation. 13 minus 9. 13 minus 9 is 4. So using these 4, we find the V4. That is 10 minus 4 is equal to 6. Okay. So we find U1, U2, U3, V1, V2, V3 and V4. Now we find the dummy allocation of these unallotted cells. Not okay. So what are the formulas for the 17% in first row? That is U1 and third column V3 minus C13. So what are the values of U1? 0 plus V3 9 minus C13, that is 17. is equal to minus 8. The dummy allocation is minus 8. Next value, U1 plus V4 minus C14. That is U1 0 plus V4 6 minus C14 14. So 6 minus 14. That is also we are getting minus 8. The same value. Okay. Next unallotted value is 16. So U2 plus V1 minus C21. So U2 is 5, V1 is 11 minus 16. That is 16 minus 16 we are getting 0. So next U2 plus V4 minus C24. U2 5, V4 6 minus 10. That is 11 minus 10 is 1. Okay. Next, this value. U3 plus V1 minus C31. U3 is 4, V1 is 11 minus 21. That is 15 minus 21 is minus 6. Minus 6. Another value, U3 plus V2 minus C32. U3 4, V2 13 minus C32 24. That is 17 minus 24 minus 5. Minus 7. So, we have to allocate the dummy values for this table. Okay, what are the dummy values? Minus 8, 0, 1, minus 6, minus 7. So, now we are going to form the loop. In dummy value, if the positive value occurs, the loop start that positive value. Okay, so we are getting the only one positive value, that is 1. So the loop is going to start. Loop is going to start, and the loop ends, each edges ends with the original allocation. Okay, so these are the possible way. So theta plus, theta minus, theta plus and theta minus. So here theta is equal to minimum of 125, 150 and 200. So theta is equal to 125. What is the theta value? Theta here is theta is equal to 125. So what we say? Theta plus, theta minus, theta plus and theta minus. In another table, we have to form 11, 13, 17, 14, 16, 18, 14, 10, 21, 24, 13, 10. So now we have to put only the original allocated value, that is 200, 50, 175. Okay. In this table, in this place, we have to change, because we choose the theta. Theta value is 125. What do you mean? That is theta plus. That is, we have to replace the dummy allocation to the original allocation. That is the 125 has to be replaced in original value. Theta minus, that is 125 minus 125, we are getting 0. So we are not put 0 in the value. Now theta plus 150 plus 125, 275. Now 200 minus 125, that is 75. So now we have to check m plus n minus 1, that is number of rows 4 plus number of columns 3 minus 1, 7 minus 1, 6 original allocation value, 2, 4 and 6. Now using these are the repeated values, using the simultaneous values, that is the u1, u2, u3, v1, v2, v3 and v4. You have to assign u1 equal to 0. So in the what is the value for the original allocation? 11. So 11 minus 0 is 11. You are getting v1 equal to 11. Next, 13 minus 0 is also 13. So now we find the original allocated 18. So 18 minus 13, 5. Next, 10 minus 5 is 5. 10 minus 5 is 5. 13 minus 5 is 8. So these are the values for the another tabular column. Now we have to find the dummy values using the previous steps. That is u1 plus v3 minus c13. That is 0 plus 8 minus 17. Answer is minus 9. Until we have to follow only the negative values are occurred in the dummy steps. Okay, next u1 plus v4 minus c14. That is 0 plus 5 minus 14. That is also minus 9. Next, u2 plus v1 minus c21. 5 plus 11 minus 16. That is 16 minus 16, obviously 0. Next, u2 plus v3 minus c23. u2, 5 plus 8 minus 14. 13 minus 14 minus 1. So u3 plus v1, another u3 plus v1 minus c31. u3, 5 plus v1, 11 minus 21. 16 minus 21 minus 5. Next, u3 plus v2 minus c32. 5 plus v2, 13 minus 24. So 18 minus 24, that is minus 6. So all the dummy values are negative. So the problem is to be finished here. Minus 9, minus 9, 0, minus 1, minus 5, minus 6. If one positive values occur in the dummy value, we have to repeat the previous steps as well. Now the optimum basic feasible solution is 200 into the optimum basic feasible solution is 200 into 11 plus 50 into 13 plus 175 into 18 plus 125 into 10 plus 275 into 13 plus 75 into 10. So these are the values of the optimum basic feasible solution. I hope you all understand the method, UV method in operation research in this video. We will discuss another method in another video. Thank you, friends.